Okay, the lesson that we're going to be working with today is actually an activity. It's 1.3 activity for the 8th grade book. Students will explore equations with variables on both sides by examining figures with unique properties. So we'll be working with some geometric figures. The standards covered are AEE, 7A, and B. Page numbers are 16 and 17 out of the hardcover book and 11 and 13 out of the practice journal. So if you have your practice journal, I'm going to have you just work along in your practice journal as I work through this activity. Okay, so to start out with, first of all, in activity 1 on page 11, it is having us work with perimeter and area. So we're going to write an equation where it shows that the value of the perimeter is equal to the value of the area. We're then going to solve for x, and then once we find the value of x, we're going to use that to find the perimeter and the area of each figure. And in the end, we will go through and check our solutions by comparing our answers to perimeter and area, and they should be equal to each other. So as we work through this, we're going to go ahead and review really quick how to find the perimeter of a rectangle. Well, when you find the perimeter of a rectangle, you work your way around the outside of that rectangle. So if this is 3, there's an x, that's 3, and this is also x. So when I look at this, I can look at it kind of like we did when we worked through the the triangles back in lesson 2. We're going to go ahead and put together everything that's there. So here I'm actually adding all of those together. So when I look at this, I have 1x and another x. I have 2 x's, and then these together, my constant numbers, are 6. So I have 6 plus 2 x's for my perimeter. Now, to find the area, you do length times width. Okay, so 3 times x, well, that's 3x. Okay, so now we're going to review working to get x's to one side. So because here's my equal sign, and I already have 3x by itself on the right side, I'm going to go ahead and get rid of my 2x on this side. It'll save me some steps. So minus 2x minus 2x. I have 6 here, and on this side I have 1x. So 1x equals 6, x equals 6. So I just found out that x equals 6. Okay, so now I'm going to go ahead and I'm going to substitute in 6 where x is. And I can either choose to go to my equations over here and substitute in. I'm just going to do it on the picture on this one. So if I substitute in 6 where I had x initially in on these figures, change back to white here because it shows up really low. This is 6 and this is 6. If I go through and I do my perimeter, well, 3 plus another 3 gives me 6. Plus 6 is 12, plus 6 gives me 18. And I don't have dimensions on this, so it's just 18 for now. Now to do area, it's length times width, so 3 times 6 gives me 18. Now I'm going to check myself. Were my perimeter and area equal to each other? Yes, they were. Okay, so here I found out that x equals 6 and the perimeter and the area of this rectangle are both 18. So let's try another one. Same thing, we're going to go ahead and solve for x. So we're going to have to set up our equation first. So let's do letter D. Now this one has a fraction over here. And if you don't like to work fractions, you are perfectly welcome to go ahead and change that to its decimal form. So I'm going to review with you really quickly how to change a fraction to a decimal. It's all in the way that we read it. So as I read this as 5 divided by 2. So I'm just going to punch it in that way, 5 divided by 2. Now I'm comfortable it's 2.5. But if you're not, you might have to use the calculator. So now I'm going to go ahead and write that here, 2.5, which means this side over here is also 2.5. And the top up here is an x because it's the same as this one, okay? Now I like to do that because I like to see everything. Okay, so when I do my perimeter, I see 2 x's, and then I see 2.5 plus a 2.5, that equals 5. So I have 2 x's plus a 5. Okay, for my area, remember it's length times width. So it's x times 2.5 or 2.5 x is how you guys are used to seeing it when it's just multiplying between those two numbers. So now I'm going to go ahead and get my x's to one side. Okay, so right now, Here's my equal sign. I already have 2.5x by itself over here, so I'm going to shift this one out. So you need to remember that if you are moving that front number and there is nothing in front of it, you have to think, right now it's positive 2x. You're not thinking the opposite of this symbol. You're thinking the opposite of what this is because you're taking the x with it. So right now it's positive 2x. We're going to say minus 2x or subtract 2x, negative 2x. Minus 2x. I have 5 equals 0.5 when I subtract x. Now I'll divide by 0.5. Divide by 0.5. Okay, remember this is not 5 divided by 5, it's 5 divided by 0.5. If you need to use your calculator, you may, but I know that when I divide this out, 5 divided by 0.5 is going to give me 10. Okay, and once again, just to review how to punch that in. Oops. You're going to punch it in like this, 5 divided by 0.5, 10, okay? So now we're going to go ahead and I'm going to substitute in 10 where I had x. So this is a 10 now, and this is a 10. So when I do the perimeter, 10 plus 10 is 20, 2.5 and 2.5 is 5, so 20 plus 5 is going to give me 25 for the perimeter. Okay, and then when I do area, it's my length and my width, or length and width, but it's 2.5 times 10, that is also 25. Okay, self-check, yes, they did end up being the same answer. Okay, so let's try one more of those. Actually, no, we're going to move on to a more complex one. So you will work through the other ones there on page, what was that, page 11. You're going to work through B and C that are very similar to this. But for right now, I'm going to, if you want to pause the video and work through those, you can. And then you can check back with me on the answers to those too. But I'm going to go ahead and move on with a complex figure. So if you're wanting to work right now through B and C, go ahead and pause your video. Okay, so we're going to work with this complex figure. And the reason it's complex is because it's composed of more than one rectangle. So we're still going to have to think our way through the process here. When we do perimeter, it is still going to be the distance around the outside. So I'm noticing here that I have some missing side lengths. I'm going to change colors here. Okay, so I've got this side that's missing. Well, that's the same as this. So that's an X. And then it looks like I'm missing a side here because remember, perimeter is working its way around the outside. Well, that's the same as that one, so that's a 1. And then I'm missing this side here. So here's the thing, to get that one, the whole distance of that length there is the same as this. So that's 3. Here's 2 of it that I just cut off for that part. So that leaves this to be 1. Okay, so let me erase all of these dotted spots. Okay, so now we're going to go ahead and do, when I look at the perimeter on the outside, and I'm just using the numbers on the outside, I see 2 x's. So I'm going to go ahead and write 2x. Plus, remember, we're adding all of our sides together. My numbers, well, I've got 3, 4, 5, 6, 7, 8, so plus 8 is equal to. Now for area, you're going to have to think in terms of I really have 2 smaller rectangles, and in the end, I'm going to add them together. So if I do the area of this smaller rectangle, length times width is 2 times 1 is going to give me 2. Okay, here I would do length times width, 3 times x is 3x. And then I'm going to add these 2 together because I've added those 2 pieces. They've slid them right next to each other. So I cannot really add these numbers because this 2 does not have an x. So I'm just going to write it out as 3x plus 2, or you could have 2 plus 3x. It's up to you. Okay, so there's my equation. So now I'm going to go ahead and I'm going to work my way to get x's to one side. Now, I know a lot of you prefer to work with your x's on the left side. I'm going to have you step out of your comfort zone and work and try and start kind of looking at these for strategy. As I'm looking at, here's my equal sign, as I'm comparing these 2 x's, here's what I'm seeing. Both of them are positive. That's a good thing. So if both are positive, I want to get rid of the smaller one so that in the end I still have a positive answer left over. So I'm gonna go ahead and shift my 2x out. Okay, this is just giving me strategy because I don't like to work with negative numbers if I don't have to. So that's why I'm choosing to move this x instead of the 3. So I'm gonna say minus 2x, because right now it's a positive 2x. Minus 2x. Okay, and what that is helping me eliminate is having to have a negative x left over. So 3 minus 2 gives me 1x. I still have plus 2, and on this side I still have an 8. So now I'm going to go ahead and get rid of anything that's with the x on this side, so minus 2, minus 2. I have 6 equals 1x. Oh, 1x equals 6, so I just found out that x equals 6. Okay, so now I'm going to go back in here, and wherever I have an x, I'm going to put a 6 in white. This is now a 6. And I'm putting that in parentheses so you don't think it's 36. Okay, so when we do perimeter, we're adding around the outside. So 6 plus 3 is 9, plus 6 is going to give me 15, 16, 17, 18, 19, 20. Now I like to go around like I did there, just so I don't accidentally miss a side. So I just found out that perimeter is 20. Hopefully I didn't mess something up there when I was adding in my head. Okay, so now when I do my area, okay, the area of this smaller rectangle we had already found was 2. And then the area of this bigger rectangle is 3 times 6, which is 18. Now we add these two together. 18 plus 2 gives me 20. Ooh, good thing I didn't mess up my addition in that perimeter. So once again, I can self-check. Yes, I did get the same answers. Okay, both of them ended up being 20. Okay, so you're going to go ahead and you're going to work through the other, I think there's 2 other problems there on page 12 that are working with complex figures. So you're going to have to break it down. If you need help, rewind and watch from the very beginning of this letter E. Okay, so we're going to go ahead and shift to the next one, which is working with surface area and volume. So these pictures are actually on page 13. I'm going to do one of them with you, and then you're going to do the other one. So our equations here is we're doing the surface area is equal to the volume. So I went ahead and wrote out what our formulas were there. Okay, so we've got 2 times the length width, 2 times the length and height, and 2 times the width height. Well, let's just do a visual, because I'm a visual person. When you do surface area, it's kind of like you're thinking of each of these surfaces as their own. And then you're really going to add them all together. Well, on a cube or a rectangular prism, depending on what we're working with, you always have 2 sides that are the same. So you've got this front and this back that are the same. So if I find the area of one of them, I actually have 2. So I'm going to set it up like this, 2 times, and then I'm going to find the area of one of them. And then we're going to simplify in a little bit. So to find the area of this rectangle or square, it's x times 6. So I'm going to write that out as 6x, because that's how you're used to seeing it written. Plus, okay, so now I'm going to switch colors. Let's work off of this one. And it's the same thing. It's going to be 2 times this, because the other one is right over here that you can't see. So if this height here was 6 on the red, it's all, or sorry, not 6, x on the red, it's also x on my blue. So there I've got 6 times x is 6x, and there's 2 of those. Okay, and then I've got the top here, or the bottom, which are the same. So I can visually see the top. The dimensions here, well, this was 6. Sorry, I'm gonna write that better. And this dimension was 6. Hey, I've got both dimensions on that. So 6 times 6 is 36, and there's another one on the bottom, so there's 2 of those. So 2 plus 2 times 36 is equal to, okay, so for the volume, it's the area of the base times the height. So the base is the same as the top. Okay, my base is actually, usually if I think of it, it's the bottom. Well, here I can see the top, they're the same thing. So it's 36, the area, times the height is x, so it's 36x. Okay, so now I'm going to simplify my front half or my left half here. So here, I've got 2 times 6 is 12x, plus 2 times 6 is 12x, plus 2 times 36 is 72, equals 36x. Okay, so I can simplify a little more, and I can use combining like terms. Okay, and some of you are wanting to shift those and get rid of them individually, but when it's the x, it does not work to do that. Okay, so we're going to go ahead and combine these and simplify our left side of our equal sign. So when I combine those, 12 plus 12 is 24 x's plus 72 equals 36x. Okay, so here's my equal sign. I already have the x's by themselves on the right side, so I'm going to get rid of this 24x. So minus 24. Remember, it was a positive, so the opposite is minus. Minus 24x. I have 72 equals 36 minus 24 is 12x. So now I'm going to go ahead and divide by 12 to get it out of there. Divide by 12. 72 divided by 12 is 6. So x equals 6. And if you're, how does she do that? You can use the calculator. Just remember, it's always top divided by bottom. Let me see if I can get my calculator to come back up. So it's going to be 72 divided by 12. Plus this will double check myself, make sure I did that mentally correctly. So x equals 6. So I'm going to go ahead and write x equals 6. Okay, so now if I substitute in here, and actually what I'm going to do is I'm going to go back and I'm going to substitute in 6's here. So 6 times 6, I would get 36 for this. And there's another one in the back. So I've got two 36's. I'm going to erase this over here just so we can erase this part. And I hope you didn't need that work, but you can always rewind the video and go back and see what I had there. Okay, so I've got two 36's. Okay, that was my front and my back. Then I've got my right and left. So this was 6 here. So 6 times 6 is 36. There's another one there. So there's two 36's. And then we already knew the top was 6 times 6. So that was, again, another bottom. So plus two 36's. So 72 plus 72 plus 72. Or I could take 72 times 3 if I don't want to do it so much. So 72 times 3 gives me 216. So I just found out that the surface area equals 216. Now I'm going to do the volume. So I'm going to substitute in this equation 6. So 36 times 6, not 366. Pull my calculator out. 36 times 6 better give me 216, and it did. So volume equals 216. These are equal to each other, so I know that I did it correctly. Okay, so you're going to go ahead and work your way through letter B on page 12 there, or actually it was page 13, the top of page 13. Okay, so you can either pause the video now and do that, or you can come back to it, but I'm going to go ahead, and shift to the last one, and we're actually going to do this one together. So there's only one question that's working with increasing the size of a figure. So it says work with a partner. Well, I'm your partner, so we're going to do this together. It says the two triangles are similar. The perimeter of the larger triangle is 150% the perimeter of the smaller triangle. So if I knew this perimeter, I could take that times 150%, which is 1.5. And then it should be equal to this perimeter. Remember, we're working perimeter. Okay, so if I do perimeter, that's where I'm adding my sides together. So I have on this one, 10 plus 8 is 18 plus x. So 18 plus x. Now I said I have to take that times 150%, which is 1.5. And then to go through and do this, that is going to be equal to the perimeter of this one. So 15 plus 9 is 24. No, I don't get to say plus 2 and then put an x behind it because those are not like terms. So I add these constants together and get 24. And then plus I have the 2x. I don't get to add them together, okay, because they're not both x's. So now I'm going to go ahead and 1.5 times 18. If you want to use your calculator, you can. That's 27. Plus 1.5 times x is 1.5x equals 24 plus 2x. So once again, I'm looking at this one for strategy because I don't want to work negative numbers if I don't have to. So when I look and I compare this x to this x, they're both positive. I'm going to get rid of the smaller one. So I'm going to move this 1.5x by doing the opposite. So minus 1.5x minus 1.5x. So I have 27 left here equals 24. And then 2 minus 1.5 is going to be a positive 0.5x. Now I'm going to get rid of this 24, so minus 24, because I want to get to find out what x is. Move this down a little bit. Okay, so now I get 3 here equals 0.5x. Okay, so now I'll divide by 0.5. Divide by 0.5. 3 divided by 0.5, if you need to use your calculator, go ahead and do that, but it's going to give me, I believe, 6. 3 divided by 0.5, because I just think of, I've got how many halves in there? I've got 6, that's right. So I just found out that x equals 6. So now we'll go ahead and, what did they want us to find the value of x? Find the dimensions of each triangle. So now I'll just go ahead and put my dimension of, this is going to be a 6, and then we'll change to a different color. And on this one, 2 times 6 gives me, this is now 12. So there are my dimensions. There is more than one way to actually do that. You could have used and just worked off of one side, but the reason that I did that, I could have had 1.5x equals 9 and then worked off of that as a one-step equation. But the reason I worked through this is because of what the lesson was teaching. So that's why I did go through there. Yes, there is more than one way to solve through this problem. So hopefully you can get through those other ones independently or with a small group or with a partner. Make sure that you check back with me on your answers just to make sure that you're understanding it.